Okay, got my pen and paper. Study alternates. Okay, so we've got statement P, statement Q, statement R. So statement P is true, statement Q is true, and statement R is true. It's always and, so it's a little upside down V. Okay. B, let's see. B is true. Okay. But oh, that's I think. Okay. And then not equal to 0, so it's not. I can just see like a squigggle line. Not Q. Okay, C. This is off. So P is off. However, now I do brackets and so not Q or not R, close bracket. Dollar flag is on, so that's not P. And okay, arrow equals to 0, so and Q. But so I can just do upside down. Oh wait, it is Q. Oh, I didn't do not Q. Okay, cool. Either no, both arrow equals 0. Okay, so this is not P because on, or should do bracket. Yeah, bracket arrow equals 0, so it'll be Q and R close bracket. We're in a truth table. Okay, so we've got P, Q, and R. Okay, also need not Q. Okay, let's do true, 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 false, 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 false. I forgot exactly how it works again. I might have to check the answer, but I might as well do it right now. True. No, it should be false, 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 true, 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 true. True, false, true, false, true, false, true, false, true, 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 false, 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 false. Okay, so then P or not Q and oh wait, P and okay. So P has to be true. So I can do false for everything else that P is not true and P yeah P is not true. Then it also has to have those two. So this is true here, false, true, false. Okay, that should be it. Suppose you know that bracket not P and Q or P is false. Okay. Truth values. I don't know what a truth value is. Shall I try it regardless? Um, let's see. Truth value. I really don't know what that is. Like the percentage? Maybe? Just look at the answers. Okay, let's see. This one, P. Okay, that's correct. That's correct. That's correct. That's correct. Next one. Yep, that's correct. Okay, truth table. I did get it wrong. That's how it works. Okay, that makes, I mean, I guess it makes more sense. It goes true, true, false, false, true, true, false, false, and false, true, false, true. Yeah, I guess I also have to create a case for not P or R. Mm, yeah, like I guess. If it wants me to, then yeah, I have to, I guess. Yeah, true. Okay, here we go. We know, okay, let's see. We know that not P and Q or Q, oh no, and Q or P is false. Okay, so disjunction is false only when both parts are false. So we must have P is false. Yep, that's true. Okay, and not P and Q is false. From P being false, P being false, it implies that not P is true. Okay, that is a fact. So if P is false, not P is true. Now, it can only be because Q is false in that case. So truth value wants me to tell the status of the probabilities here. So therefore, yeah, okay, P is false, and so is Q. Because if P is false, that means not P is true. Yeah. Yeah, okay, cool. Let's okay. So for which of the following, write down the truth table for the statement and determine whether the statement is a tautology, contradiction, or neither. Okay, sure. Let's go. We got P, Q, and R. Let's do the truth table properly this time. So we got true, 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 false, 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 true, true, false, false, true, true, false, false. Okay. True, false, true, false, true, false, true, false. Okay. Then we have, okay, we should probably do the probabilities of P and Q, K, and the probabilities of, do the probability of not Q as well. Frick. Okay, I'll do not Q right here in the middle. Not Q, something like that. And then also the probability of Q. Oh, okay. So P and Q is true here, false, false. After that, it is false for the rest of the things. It's and. Okay. So then not Q is false, false, true, true, false, false, fuck, false, true, true. Okay. Q and R, true, false, 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 true, false, false, false. Okay. So let's do another one. Let's run out of space in this book, bro. P and Q, or Q and R, or not Q. Okay, let's see. We have a true statement. We have a true statement in P and Q. Okay, we have a true statement in P and Q again. A true statement in not Q. True statement in not Q. True statement in Q and R. Wait, where am I? 1, 2, 3, 4, 5. Yep. There is a false. That is odd. Is that actually meant to be a false? Let's see. P and Q. Okay. False. Yep. Not Q. False. Okay. Q and R. Q and R. No, but R is false. Okay. So it's false. Then true. True. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I got them all. Now, is this a tautology, contradiction, or neither? I think, let's see. So tautology, contradiction, okay. Tautology means it's always true, contradiction means it's never true. It has to be false. Well, I'm pretty sure that like hmm, it's neither, right? Because there's a false right there. Okay, sure. Next one. Let's get P, Q, R. What else do we need? We need not Q, K, and not P. So true, 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 false, 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 true, true, false, false, true, true, false, false, true, false, true, false, true, false, true, false. Um, Not true, not true. What the fuck? False, false. True, true, false, false. True, true. Um, Not P, so it's false, 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 true, 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 true. Okay, now let's get the variables in here, which is not P or Q, okay? And then P and not Q. Okay, sure. Let's do this. So we've got not P or Q. We've got Q is true here. Okay. Both are true. Fuck. True. Then it goes false, false, true, 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 true. Okay, cool. Next one is P and not Q. So we have got a false, false, true, true, false, 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 false. This is therefore a tautology. This is a tautology. Technically speaking, um, it is all. Yeah, it is all in the middle. Fuck. Okay. Technically speaking, I'm pretty sure. There's surely a formula about this. E and well, it has to be right. No, maybe not, because the signs are kind of mismatched and shit. I mean, I feel like there would have been a rule for that, no? Hmm, maybe not. But it is a tautology. I just don't know if I can prove it using the logical equivalence laws. Maybe I can, maybe I can't. Okay. Let this denote exclusivity, which means or but not both. The truth table is supposed show that it's equivalent to so many truth tables, man. Sure. Let's get P. I've only got P and Q this time. This is good. I think it goes true, true. Oh wait, it's a table right there. True, true, false, false. True, false. True, false. Cool. So we've got not P, okay, and not Q, which goes false, false, true, true, false, true, false, true. Okay. Then we've got uh, P or Q. So P or Q goes true, 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 false, and not P. Okay. So we have to now do this and not P. So therefore, and it is and. Okay. So therefore, that is false, false, false. Oh, wait, no, no. False, false, true, true. Okay. Then we have Q or not P. So Q is true. True, false, true, true. Wait, and. Ah, one sec. True, false, true, false. Oh wait, not P. Yeah, false, false, true, true. That means it can't be stupid. Fuck. That means it's false. false. Okay, false, false. Then not P and Q is true. Okay, that's false again because P. Okay, sure. So they're not equivalent. I hope that's an answer I can give. Let's keep going. So I got three variables this time. P, Q, R. True, 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 true. False, 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 false. True, true, false, false. True, true, false, false. True, false, true, false. True, false, true, false. Okay. Now let's do P, whatever the fuck that is. Q, which is or, but not both. So it is false, false, true, 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 false, false. Okay, cool. And then we have P and R, which is true, false, true, false, 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 false. Then we also have Q. The fuck? Which question am I even doing? Ah, this one. Okay, cool. Therefore we have, well, actually we got Q and R, which is true, false, 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 true. Well done, true, false, false, false. Okay. So first of all, you have to do one side, which is um this one. Okay. And R and R. Okay, so we got false, false, true, false, true, false, false, false. Okay. Other one we have this. Oh, we have all, but not both of them. So we have these two. Okay. So that's both of them. So it's false, false, true, false, true, false, false, false. So they are equivalent. Okay. Cool. Using the laws of logical equivalence, can you prove that don't is that? Ah, okay. Has to be a way, right? Let's see. Let's write this function. Boom. And Q equivalent to P or Q and not P and Q. Okay, what laws do we have? Let's see. There's nothing with the little symbol though. Unless I can like do some manipulation, I'm not sure how. Um, hmm. How do I get the R to the other side? Um, I have to do R to everything. There's no R in this equation. The hell? There is no R. Oh, wait. All I have to do is get from that to that. But there's no formula for that. What do I do? I guess I'll just apply. Wait, no, I need to merge them together somehow. What I've got right now is this. Like, shouldn't be doing that. Should I? Oh, maybe I can actually. Hold on. Wait, hold on. Let's get the negatives. So we got P or Q. It doesn't change anything though. And then we have and not P or not Q. Fuck you. Gotta finish this. Okay. Then we can get P and Q with P and Q. Okay, we can do this, something like this. But we can't. Oh, okay. Um, hmm. We have this rule right here, absorption laws. But how can you use the absorption law if there's nothing to go off? I could use double negative laws, but I don't have a double negative here to apply. Unless I apply negative to everything. I don't think that would really help me. Hmm. Okay. Hmm. This and this is tautology, this and that is a contradiction. Hmm. Okay. In P. P dot. We're supposed to expand them? Damn. I have to only prove this one, right? Okay. Like, okay. Dude. Can't use a truth table though. So, like. What I have to do? If I put it back in the entire thing. No, because I expanded out the brackets, right? So then, how the fuck can I do it? Like, dude. Okay. P and P or Q. Okay. P or Q is a tautology. Wait a minute. Fuck, it isn't. Take it back. Oh, okay. Never mind. Dude, genuinely, how do I do this? Should I skip it? Maybe I definitely can do the other one. Like, we have not, not P or not Q. We can just do double negative law, right? So we can put to write the proof out, otherwise I won't get marks in the exam. Double negative law. Okay, so then we get not P is equivalent to P. So then we have uh P or Q. Therefore is equivalent to P or huh. Wait a second. That's not. Hey, hello. One sec. What the fuck? Fuck. Ah, right. We have to expand the shit out. Whoopsies, wrong law. It's actually De Morgan's. Yep, that's it. De Morgan's law. We get uh we get De Morgan's and double negative. Uh I think we write the De Morgan's as if it's not P or and then it would be and, not q. And then we do double negative. Might have to go ask help with that. If you do double negative, not the double negative, that was the law called. Just called double negative law. Then we get p and q. Yeah, so I think that's how we do it. Next one. Oh, gee, what it is. Not p or not q. Oh, okay. Or not p, fuck p, and not q. Okay, it's equivalent to not p. Okay. Let's see. Anything more we can do? First off, expand it out. I don't know what that give us though. Tell you what it would give us. Tell you what it would give us. Tell you what it would give us. If we expand it out, if we used Morgan's, the Morgan, okay, and we get not P and Q or yada yada, we can move them around so we get Q and not P or yada yada, not P and not Q. Then we can use, if everything's negative, we can just use no associative. The hell? There's a rule here. Ah, yes. Absorption. And they are opposite signs. So then it becomes, okay, so then Q and not P is equivalent to not P. Am I doing that right? How do I go to the Q? Oh, shit, I made it mess up. Because that's not actually equivalent, so I must have messed something up. Okay. Like, could apply a negative to everything. What if we apply a negative to everything? So then we just get P or not Q, right? Or wait, do we get that? Oh yeah, we do. We get P Q. Oh, wait a minute, this is somewhere. This is somewhere. Hold on. Is it or? Wait. No. Shit. No. Wait, it's P. Wait, hold on. I actually got it. Actually got it. P and P or not Q. Okay. And then we have it's in a bracket. Okay. Or uh so we add a negative and we apply that, so then we first of all we flip the sign, we get P, okay, and then we flip the sign so it becomes a and wait, which one are we doing? Second one. Yep, okay. Then it becomes or Q equivalent to not P. So then we have P or not Q is equivalent to not P. The fuck? Did I do that right? Wait, am I stupid? What did I actually get? I do that law. The opposite signs. It's the same sign. Shit, dude. I'm perplexed. Okay, maybe I look at the answers. No. Okay, well, honestly, fuck it. There's another question. Uh, it's not true. No, I'm sorry. So, right set. What does it mean use Morgan's law to write sentences equivalent to the following? But it's true that I'm not Q and wait, not not P and Q, which gives me uh, not P or not Q, I guess. Uh, so not E or Q gives me not P and not Q. I think that's what's asking me. Okay, let's see. First one. Shit. Which one is that? Sec. You must have written that down, right? There's no way I got that wrong. Ah, here it is. P. Yep. Neither. Okay. Cool. That's correct. We have phone ancestors tautology. I got it correct, but did I not write the full equation? Yes. Which question is that? Hmm. Yes. Um. Did they agree on every rule? Oh, how did I get that? Hold on. Or not P. And not P. So P and P or Q and not P is true. No, wait. Yeah? Hold on. Not P is true, true. P or Q. Why the hell did I write that it's true? Oh, because my P there didn't have another F. Okay. That's entirely my fault. God damn. Oh, this one I did get them to match though. Okay. See. Okay. This is how we do it. Driving. Okay, what question was that? I should actually just get the question now. Okay, I got the question written down. Never mind. Okay. Okay, but how the hell can we just get that, dude? Dude, that is crazy. Like, I get it. I get it completely. Honestly, I do. Because if we have this already done, right? Right. We know this is true. And we know that this one is equivalent to that, right? We know that. We can just write them as the same thing. Wait, what? Columns for that and that match that and that. What are those actually from, dude? This one and this one. Okay. Hence, it's our original statement. Why is R in here? Oh, wait, no, C. Oh, wait, we know this. Oh, this is a given statement. We weren't meant to prove it. Wait, so we know that. Oh my God. Then we just have to use that logic on here to expand out the second part. Oh, God. Okay, I get it now. What about 3A though? Double negative, De Morgans. Hold on a second. I definitely double negative to get P. That's stupid. Double negative flips the sign. Right. Yeah, not P, just P. Oh, what? We use double negative first. Ah, I see. That's what we do, huh? Okay, I guess. We wrote this down. Not P and Q is also somehow equivalent to adding a bracket. That would make so much sense. It makes it why my other stuff wasn't working beforehand. If we apply De Morgan's, oh, why not change? Did change. Okay. I did that step. Yes, there's a point where I did that step. I did not change the sign. Wait. Uh, wait. No. De Morgan's. I did that step. Okay. Well, we'll do it again. So we have not P and Q or yada yada. Distributive law. The hell? P? But there's three variables in here. Oh, you want me to go back? Oh my God. Q and R is a Q and not Q. Oh my God. I can go backwards from that with any three different variables I have. Okay, okay. So if I have not P or yeah and Q or not Q, because I can go back. Okay, distributive. It's down. Distributive. And go back. And it's a tautology. It's a tautology. See? P or not P. Therefore, that's a tautology. Then anything with a tautology, anything what? X don't where is that identity law? Oh, here we go. P don't is P. Okay, that's not P. Yep, okay. Sure. Let's do this. I already did that, but I have not P or not Q. Okay, that's correct. I should have to write out the full statement. This is an exam. Okay, that makes sense. And you have not Q and S. Hold on. I'm going to the movies this weekend, and S is I'm going swimming this weekend. Wait. I'm not going to the movies this weekend. Or I'm not going swimming this weekend. Ah, okay. Yep, that makes sense. So it is indeed not Q. Yep, not Q. Or not P. I just reversed by accident. And we can reverse the Morgans to get the original statement, which we had from actually 4A, which is Q. Oh fuck. P and Q. Okay, that's cool. I'll do some more later. Oh shit, what the hell? Uh, okay, on the bypass. Fusions. Problems. Oh, they have extra problems. If I wanted to. I mean, not really, preferably. You know, page 17 of 198. 3. Jesus Christ. Oh, I'll catch up. I'll catch up eventually. Yeah. Yeah. That's unfortunate, dude. Can't lie.